Good morning, everyone. Can everyone hear me and see my screen?
Yes.
Hey, Deanna.
Hi, Becky. How are you?
Good. Good. All right, so we'll give it one more minute and then we will get rolling since it's already 10:01 or 11:01, depending on where you're at, or 8:01 if you're on the West Coast, or 9:01 if you're in Vegas or Colorado. All right. So it's 10:02, so we'll get started. For those of you that don't know who I am, my name is Becky Danielson, and I am the chair of the Fall Protection Council for SAIA. And we are rounding out our four-part series in fall protection equipment inspection. We started with harnesses. We moved into connectors, which is lanyards, snap hooks, carabiners, and then we went into SRLs on the last one. And now we're hitting vertical lifelines and anchorage connectors. Excuse me. So as you can see on this, hopefully you can see my screen. So we have vertical lifelines. So when we talk about vertical lifelines, that's going to typically be that rope. So there's two different versions. So you have a temporary vertical lifeline and you have a permanent vertical lifeline. So temporary vertical lifelines are what you guys normally use out in the field. Vertical is on a fixed ladder that is a cable that you guys don't tend to run across very often, but we'll talk about it real quick. So vertical lifelines consist of rope. Now there's two different types of rope that we kind of see as a on an average as a whole. So we have like a copolymer, which is more like and a lot of manufacturers will use it's either blue or yellow that you'll see out in the field, and it's more of it feels almost like a plasticky material, but it's a very high strength rope, but it's not as durable. Um, as some of the other ropes that are out there. And then we have polyblind rope, which everybody kind of is used to. It's on the screen. It's the white with either blue tracers or blue and red tracers or black tracers, or depending on the manufacturer, whatever tracer they use in it. Uh, so that's that polyblind rope, which is a kind of a polyester blend rope that has a little bit of stretch to it, not a ton, not like a dynamic rope. And then you're starting to see more and more, and Sean and I actually just had a conversation about this not too long ago. Kern mano rope. So Kern mano rope has all the strength on the inner core, and the outer core is just a protective sheath. It's not as common when it comes to vertical lifelines, but we're starting to see more and more of that. Um, and so then we also have the rope grabs that we see out in the field. So we have automatic rope grabs and we have manual rope grabs. So automatic rope grabs we typically see in a vertical application. So if I'm going up and down, whether I'm a window washer, I'm on a suspended platform, or I'm climbing up a ladder or whatever, so then I would have an automatic. So it would allow me to maintain my 3 points of contact and climb up and climb down, and it would be behind me. And most of them have the big rings. Some of them don't, and they're all a little bit different. I just threw a couple of the pretty common ones that I've seen in the field out there. And then we have manual. Now, manual is typically used in a horizontal application. You'll see it in residential roofing. So they manually open it to move it, lock it, and kind of create a restraint system out of it. So we use them a lot in restraint rather than the fall arrest side of things. And they can be used in vertical or horizontal, but it takes manually moving it up and down where the others just trail along with you. Now to do the inspection on those, so I have like a manual rope grab right here, but basically it's the same thing that we talked about when we talked about harnesses and lanyards and SRLs when we do that inspection. So it's all still the same things that we look at. We look at whether there's webbing or the rope. We look at the labels, making sure that they're there and they're legible, which this can get kind of tricky. Not so much on the rope grabs themselves because most of it is etched in. Every once in a while you'll see some manufacturers will put a sticker on there, but most of the stuff is etched in there. Um, and then the lanyard itself. Now, remember, and this is I'm the messenger, so no killing me. But remember that almost all of the manufacturers, and trust me, I have read every single manual for every single rope grab that's out there, that they all state that you can only use a 3-foot lanyard with their rope grab. Now, some manufacturers have gone to the extent that say, basically, if you want to use something longer, and yes, I know it's frustrating, especially in some of the bigger platforms, if you want to use a longer lanyard, you do the testing and you take on that liability. But everything that they do, and the reason for that is because remember, OSHA only recognizes a 6-foot free fall. And if that is trailing you, it's down 3 feet because that's how long the lanyard is. It's going to take you 3 feet to catch that lanyard and then 3 feet below for that to actually lock off and engage. And so that's where that 3-foot lanyard comes into play. And in Canada, they've gone to the extent where it has to be an integral part of, so it has to be sewn on to the rope grab that you cannot take it off. And it's 30 inches is what they've gone with. So it's like like right around 2.5 feet to eliminate people putting something longer on there. The rope grabs are only designed for that amount of free fall. So they're only designed for that 6 feet of free fall. The rope brand new will probably do all right, but if that's been out there for a year and damaged or whatever, there's a bigger problem in there, right? So when we inspect rope, the regular, but like the copolymer and the polyblend rope, basically you're looking for any um, fraying, or if you a lot of times they're the 3 strands, or you can twist them and then it'll kind of open up and you can see all of it. So basically you twist the rope, or you're inspecting to make sure that you don't have any heated spots. Sometimes that will happen when you overload the rope grab. It'll get like where it does the initial lock off, and so you'll get the heated, or you're using something hot around it and it melts it. They all of them will melt no matter what rope it is. Uh, and so basically you're looking for any kind of fraying, and then whatever, if there is a metal connection on it. Some of them have a large pelican hook, some of them have a small snap hook, some of them have carabiners, some of them will just have the thimble end, that you put a carabiner in, making sure that you're inspecting the thimble end where it's connected. If there's no end, especially with kern mano rope, the knot that you put in it, you want to make sure that that is still secure. And then um, again, you're checking if it's got the snap hook on it, whether it's big or small. You want to make sure that that it's still functionable. You're looking for rust, corrosion, anything that affects the integrity of the metal, right? Just like we talked about with every other piece of equipment, we want to make sure that if it if we feel like it's affecting the integrity and the strength of it, whether it's the strength of the rope or whether it's the metal or the thimbled end, or we're starting to see things pull apart, those all come out of service and need to be replaced. With the rope grabs, there are a few things that we look at. So when we look at the rope grabs, and most of them, except for I think one manufacturer, they have teeth on the inside. And I know you can't see it, but you all have rope grabs at your site. So there's kind of teeth in there. And each manufacturer will basically say, some manufacturers put like a line on it that'll tell you if the teeth are worn down this far, then it needs to come out of service. But you want to make sure those teeth aren't completely worn all the way down. Otherwise, it's harder for it to lock off. Rust, corrosion, anything that affects the integrity of that metal. Also, if there is a reason that there's a lot of them that have the twist that open, so like the middle picture and the other picture shows it open. If it won't close all the way and there's something that's damaged in it, a lot of times what'll happen is there's a little arm or a spring that can get damaged and won't allow it to close, um, as well as they call it an anti-gravity pin, so that if you were to invert that, put it upside down and try to put it on the rope, it won't close. Um, that's not to say that you couldn't put it on the rope upside down, but it's supposed to deter from being able to put it on upside down. So again, just like everything else that we've talked about with all of it, it's inspecting its functionality. Does it close all the way? Um, is there anything that's allowing it not to? Is any of the springs broke? The other thing that you want to do when you put it on the rope, whether it's manual or automatic, is test it. Make sure that you pull down in that locked position to make sure it kind of stays on the rope, and then release it so that it will move up and down. And always remember best practice with vertical lifelines. Always take the rope grab and park it above your head. That reduces the free fall, which reduces the amount of force on our body, which also reduces the amount of force that that rope is going to see. Keep in mind that if you're using 200, 300 feet of rope, anytime we get over like 150 feet of rope, that's going to have a good chunk of stretch to it. So make sure that you're keeping that in mind when you're talking about your clearance calculation, right? That if someone were to fall, there's going to be that stretch to that rope. And the longer the rope is, the more that's going to have a little bit of give to it. Um, so what I'll do is, so remember 3-foot lanyard, most manufacturers all say that. Uh, if they allow you to use something else, basically you're taking on that liability. You've done the testing. You can prove that it works that way. Um, and I've only seen one manual that states that. All the rest of them don't state anything else other than you're only allowed to use a 3-foot lanyard with that rope grab, with automatic rope grabs. And most of the time with the manual, it'll say 3 feet or shorter. So any questions on vertical lifeline inspection before we jump too far into Anchorage connectors? Did you all fall asleep on me? It's okay if you did. It's early. You can use the chat feature too if you don't want to unmute and
Oh,
talk
all good,
smart.
Becky. All's good, Becky. Thank you.
Sweet. Okay. The other thing I wanted to say with Kern mantle rope, when you do the inspection on Kern mantle rope, if you're using that, you can use a rolled rope test. So basically you roll the rope because the strength is on the inner core and there's all these strands that are on the inner core. And so if you roll the rope and all of a sudden you'll see it like flop flat against, then you know it's been either overloaded or heated on the inside or damaged. And so it should just roll, like it just kind of you just keep rolling it. If you puncture the outer core and you can see the inner core, then it needs to be removed from service. If it gets hit with anything hot and all of a sudden you can see the strands on the inside, then it needs to be removed from service. Because remember, Kern mantle rope, the strength of it is on the inside, and then the outer shear is the protected. So, and that's a really easy way to test Kern mantle rope. The best way to test any rope or to inspect any rope, dump it out of the bag, and then as you feed it back in, you're looking at it, you're feeling it like you know, going through your hands. Make sure that you're wearing gloves, just like we did with SRLs. You want to make sure you wear gloves with rope because as you pull fast, you can get those rope burns or whatever. Um, so then we will go to, let's see if I can do this right now. Now, can you see the Anchorage connectors on your screen? Hopefully.
Yes. Yes, we
Okay,
can.
perfect. Thank you. So anchorage connectors. So anchorage connectors are anything that connects us to the anchor. Okay. So anchorage connectors consist of, and this is just a small handful of anchorage connectors that are out there. And we'll touch real quickly. Tie back anchors and fall protection anchors are not the same thing. So tie back anchors I'm not covering in this because it's different. Tie back anchors are specifically designed for tying back equipment. Now they can be used in some manufacturers allow them to be used in fall protection. But if you were to, and they're tested, right? Whether it's biannually in California or annually, tieback anchors are tested. If you test a fall protection anchorage connector, you will deploy it and it will come out of service. So we won't get into the testing of anchorage connectors. So anchorage connectors are, let's say that I can't anchor to a flat roof, right? So, or whatever structure, whether it's my lanyard or SRL that doesn't fit around it or anything like that. So now I need an anchorage connector, something that will loop around that fits, that's designed as all of the ones that you see on the screen are all designed for 5,000 pounds. Okay. And those of you that know fall protection anchors, an improvised anchor, meaning I'm looking at that as a competent person or a qualified person, and I both can make this decision, and that I believe that that is going to hold 5,000 pounds. How on earth do we determine that? And we're trying to get better at this and get better verbiage with it, but right now it's, do I think that will hold an F-150 at a static load? Yep. If it's electrical conduit or sprinklers, yeah, probably not, right? So the anchorage connector is anything that we're going to connect to the anchor that allows us to connect our connecting device to that. So now it's me with my connecting device to the anchor or anchorage connector. We have beam gliders or beam clamps. One is fixed and one it moves along with me. There's concrete anchors, there's toggle anchors for steel. The common ones that we see are the yellow one, which is a scaffold choker. So it just fits around that beam, making sure that the beam will support what we want it to. So an improvised anchor is 5,000 pounds. A certified anchor is stamped off by a structural engineer, looked at by a qualified person, and that has a 2-to-1 safety factor for fall protection. And what that means is that whatever I believe is going to be the worst case scenario that it's going to hit with, times 2. Now we know in fall protection that if we're using a system that is designed to keep the fall arrest forces at a minimum because of the law, 1,800 pounds or lower, times 2 is 3,600 pounds. So potentially you could see a certified anchor in the field that's only rated for 3,600 pounds. And that is assuming that only one person is going to be attached to that anchor. Okay. So anchorage connectors. So again, when we talk about inspection of all of our anchorage connectors, and there's a bajillion of them out there, I just threw some pictures of some of them out there, mostly the most common ones. So the red and black one that you see is a tie-off adapter or an anchorage sling, some people call them. They have a lot of different terminology for that one. An anchor strap. So basically when you look at that, and most of them are two-tone, so you'll see the weight-bearing strap will be one color and the wear pad will be another color. Some manufacturers still have the same, I think DVI still has yellow on yellow, but a lot of the other manufacturers will have a different color so that it's easy to tell. If the wear pad is damaged, I'm not as concerned about that. What I am concerned about is if the weight-bearing strap is damaged. And remember, the wear pad, when we put it on a structure, the wear pad always goes to the structure. So the easiest way to remember that is I want to be able to see the labels, because the labels are always on the weight bearing strap. So if I can still see the labels when I choke it on, and both of those have to be choked. So this is where you take your rigging brain and you set that aside, because you can't basket hitch any of these. They have to be choked. That's why they're designed with one small ring and one big ring to go through each other. There are some cable ones out there that can do different, but for the web ones, they have to be choked. So if you see a big ring and a little ring, they have to go through themselves. And if you're using a web strap like the tie-off adapter or anchor strap, and you're using it with a horizontal lifeline, it has to wrap around the structure twice. So it has to be long enough to wrap around whatever anchor you're attaching it to twice. Um, just kind of a side note with horizontal lifelines, um, or rat lines, or whatever anybody else wants to call them. So again, we look at all the same things: webbing, stitch patterns, labels, um, and then the metal. So webbing, cuts, frays, holes, burns. Remember, we're allowed 1/16 of a cut, fray, hole, or burn within any of that webbing. And then the stitch patterns. Remember, some manufacturers allow 2 broken stitches. Most manufacturers only allow 1. If you find a broken stitch, that's the strongest part, I would remove it from service. Labels have to be there. They have to be legible. Remember that the serial number is what ties it back to the inspection records. So whether it's all metal or whether you've got webbing and stitching, all of those same things that we've talked about in all the other webinars, they're the same, right? And then we look for rust, corrosion, anything that affects the integrity of the metal, specifically on the D-rings of all of those, because that's where that's going to be connected to, right? Deformity, remember that we talked about in connectors and in harnesses, deformity of a D-ring is not from a fall, it's from misuse, because they're extra rated. And then, so we have removable anchors. Those have specifics, and each manufacturer might say something a little bit differently. So you're gonna have to refer back to the manufacturer's inspection criteria for that. But even on the bolt-in anchors, you're looking when it's already in, you're looking at what's exposed. So there's a bolt end that's exposed, and then the swiveling D-ring. So looking at metal, rust, corrosion, anything that affects the integrity of the metal, right? So for anchorage connectors, remember that these are, all of them are rated for 5,000 pounds, and that they're only as good as what we're anchoring them to. And so I'm trying to think if I missed anything with the Anchorage Connect. And then there's so many more out there. But remember that fall arrest anchors are not the same as tieback anchors. But yes, some manufacturers allow tieback anchors to be used in the fall protection. But remember that anytime that you are using any anchor, especially on a rooftop, and you are tying to it, it can only have one straight vertical pull. So only one rope can be attached to that. If you're attaching a vertical lifeline or whatever you're attaching to it, it's only designed for one person. Um, and so and you can't tie anything else back to it, right? So making sure that you only have, in fall arrest, it's one anchor, one fall arrest system. I think I've covered most of it. So any questions? You can unmute or you can use the chat feature.
We're good.
All right. And all of you know that you can reach out to Jackie or myself. Jackie can get you in touch with me if you have any questions in the future, or offline, or anything like that. I will be putting together and sending it to the review committee sort of slide deck of damaged equipment so that it's kind of easier for you to, it's hard with a camera to kind of, see everything. So much like what we did with the others, we have some damaged pictures of equipment. So we'll make sure that those get out there as well. All right. So I think we're good. If nobody has anything.
Oh, we're good here on my end, Becky. Thank you.
All right. Awesome. Thanks to everybody for joining this morning and have a great rest of your day. Stay safe out there.
Thank you.
Thanks, Becky.
You bet. Bye.